Okay, I have a balloon, and the volume of this balloon is 5 liters, and it's at 1 atmosphere, and it's at, you know, it's a cold day, it's 273 out, and I let my balloon rise. As the balloon rises up into the atmosphere, the pressure goes down, and the temperature goes down. So the question is, what would be the volume if the balloon reaches an altitude where the pressure is 0.1 atmosphere and the temperature is 173 Kelvin? Now what we're going to do is we're going to use the two-state approach. I have an equation, PV equals nRT. And at state 1, it's this volume, this pressure, and this temperature. At state 2, it's at another state, it's the volume we're after, this pressure, and this temperature. Now if I divide, so I'm going to call this P1, V1, N1, and T1. Now I can divide this by P2, V2, and I can divide this by P2, V2, and they're still equivalent, because if I divide something by the same thing. But since P2, V2 equals N2, R, T2, I can rewrite this as N2, R, T2. So I've taken one state and divided it by another state. So over here I'm going to make a table. It's important that you make this table so you don't get confused. And this is going to be my state 1, and this is going to be my state 2. Okay? And I'm going to have over here a volume at state 1, a pressure at state, a temperature, and a number of moles. Okay? Now, I want to solve for volume, so I'm going to solve this for volume, and I'm going to write this as V1 equals V2. I'm going to bring this up here. And now I'm going to have an N1 over an N2. My R over R cancels, and I have a T1 over T2. Now I need to make a note here. Temperatures must be in the units of Kelvin. This is because of this R. Okay? And now I bring my pressure to the other side, so I have a P2 over a P1. So now I've solved this for my variable, and I choose which state is which. So state 1 is going to be the upper atmospheric state, because that's the state I'm solving for. So V1 is my question mark. In the upper atmosphere, it's 0.1. The temperature is 173 Kelvin, and this is ATM. Okay? And I haven't been given the number of molecules. So I'm just going to call this N1, whatever it is. Now I go to state 2. State 2 is the state that I already know. So this is at room conditions. So my balloon has a volume of 5.00 liters. The pressure is 1 atmosphere. The temperature is 273 K. And the molecules are N2. Now I assume no molecules enter or escape. What that means is that N1 equals N2, and so this effectively cancels. However many molecules I have, I had the same number before as I do after. So now I start substituting in, and my volume at state 1 is equal to the volume at state 2, which is 5.00 liters, times the temperature at state 1, which is 173, over the temperature at state 2, 273, times the pressure at state 2. And what you'll notice is each of these is dimensionless. Temperature over temperature has no units. Pressure over pressure has no units. So my final answer, volume, has the units of my volume at state 2. So I want pressure at state 2. This is state 2. So the pressure at state 2 was 1 atmosphere. State 2 was my room conditions. And at the upper atmosphere, it was 0.1. Okay? And incidentally, if this had been torrs, I could have left these in torrs. Okay? If this had been pounds per square inch, I could have left these in pounds per square inch as long as what was in the numerator and the denominator was the same. But you have to be careful of this one. This must be in Kelvin. Okay? Now I bring out my calculator, and I come up with a value of 31.68. So we'll call this 31.7 liters. Okay.